Hello, I am Mihai, like the popular song, it's Mihai. And I will talk to you about open source, security, and Bazel. I worked 4 years building TensorFlow security team, and then I switched to Google open source security team. So I'm talking in that context. Okay, so why open source? It's used everywhere, including like the recent NASA missile rocket that got sent to space yesterday. Everything uses open source. The problem is open source has a big problem. And that problem is dependencies, dependencies, dependencies. You have a dependency that has dependencies, and so on. And you never know if your tiny dependency that is very deep down in your tree got migrated to a different maintainer. Or if the maintainer is upset about the current situation and suddenly decides to remove its entire code base from the repository, from the upstream repository. Or decides to serve ads into your own dependency. So now when you are building, you are seeing ads in your terminal. So you have all of these supply chain issues. Some of them are benign, some of them are malicious. We need to handle this issue. And there is a problem, a big problem. The number of attacks on supply chain is on the rise. So last year, in 2022, the number of attacks on the supply chain has been 742% larger than in 2021. And this is going to be an exponential increase faster than Bitcoin at its height. Okay, so let's look just at the attacks from last year. This is just a timeline of the ones that made significant press. And even here you have two categories, those that made press for a week versus those that made press and are even now still in consideration. Like for example, Log4j, there are still a lot of scenarios where vulnerable Log4j is still being used. And we started the year in January with some researchers trying to prove that they can inject malicious code into the Linux kernel, proving that the saying that all eyes make bugs shallow is actually false. You can have 1,000 of reviewers on the open source repository, and vulnerabilities can be still snuck in. We had in September the Travis CI credentials leak, which allowed anyone to alter the build pipeline for a project and insert their own malicious code while you are building your own project. And then Log4j in December last year, which destroyed a lot of Christmas holidays for a bunch of people. Okay, so what happened at Google? Google created last year, incubated this Google open source security team. We have a saying with GOSST because the name says ghosts. And we are handling this problem with 4 different pillars. The first one is supply chain and build integrity, and that's the one that I'll focus most about right now because that's the one where Bazel is involved. And there are 3 others where we are looking at risks, at vulnerabilities, and how to handle them once we know that they exist. So for the supply chain security, let's look a little bit more at the picture. So for most developers or open source packages, the scenario is simple. I have a developer, they write code into a source repository, and then sometimes later, somebody executes some artifact from that repository. But the thing is not that simple. First, the developer can submit bad code, and then some hacker can abuse that and abuse the privilege, and while you execute the code, take over your system. But the more complex issue is that the entire story is much more complicated. Actually, from the source repo, you have to build the artifact. And when you build the artifact, you have a bunch of dependencies that you have to pull in. And for each of these dependencies, imagine a similar chain. Once you build the artifact, you have to deploy it. For example, you have to upload the wheels to PyPI. Or if you are building some Java packet, you have to upload it to Maven Central, and so on. Once the artifact is built, somebody needs to download it to execute it. This download can also be altered. If you, for example, if you are not using HTTPS, I hope everyone uses it now, but it might happen. It might be altered. Or somebody could take over your account on PyPI and upload malicious packages on behalf of you. So each step in this supply chain has actually a potential for an attack. And it turns out that doing supply chain integrity handles most of these scenarios. So we'll only have to care about submitting bad code, injecting vulnerabilities, and then handling them. So that's why this is handled by the other 3 pillars of GOSST. So now let's look at the supply chain integrity stack. I'm saying stack because there are 4 levels. First, we need to trust the actors. So I need to trust that This is the developer of, let's say, TensorFlow. This is the developer of curl, and so on. I need to trust that when this developer of curl says that this curl package has been built from this repository, I need to trust the entire thing. Once we have the trust foundation, on top of that, we can build attestations, basically a statement about a product. Like I can say, this curl version 1.2.3 has been built from this repository at this commit. That is like an attestation. Once you have a lot of attestations around, so another example of an attestation could be a vulnerability attestation saying TensorFlow is not vulnerable to this libpng vulnerability because we are not using that function that is vulnerable. So once you have all of this attestation together, somebody needs to aggregate them, and then at use point, at the user, you decide, do I trust that this software is secure, that my supply chain is secure or not? So for the policy and insight layer, you can imagine like in 2024, NASA would say, from now on, we only trust open source software that has been developed on GitHub, that has attestations for the entirety of its supply chain, or that has been developed inside NASA. So that is the policy and insight layer. And now let's go a little bit over the first three layers. So for the trust foundations, we have the project Sigstore, which aims to be let's encrypt, but for software artifacts. So as a little bit of a side story, this week I was working on releasing my blog. I made it work on port 80 on HTTP. And then I got let's encrypt. It had a command line. I ran it. I pointed it to the Nginx configuration. It generated certificates for me. It updated the Nginx configuration to support HTTPS. 2 minutes, I had everything set up. Sigstore wants to do the same for software artifacts. You are building an artifact from your repository. You are releasing it. You are going to run some commands, and you are getting a short sign certificate that allows you to sign that artifact for its duration. You no longer need to care about the lifetime of your certificate. Previously, without Sigstore, when you'd sign an artifact with PGP, you would need to consider how am I going to store the PGP key? What happens if my signing key gets lost or gets stolen and then somebody starts signing artifacts with my key? With Sigstore, you don't care about that because the certificate is valid only for around 10 minutes. So you no longer need to care about this. But now, because the certificate is short, there are other problems that we need to consider. One of them is how do we tie the certificate to the identity? And for this, we use OpenID Connect. So when you start signing an artifact with Sigstore, it will open an OIDC login page, and you can log in with GitHub, Microsoft email, Gmail, and so on. And that would tie your certificate with your identity. The other problem that we need to solve is how do we know that the software that got signed with this certificate got signed during the time where the certificate was valid? And for this, Sigstore provides a transparency log where every signature is stored in there in an append-only fashion. So if you sign a certificate, if you sign an artifact, that is stored in the transparency log and will never be removed. And then there are verifiers that can look at this log and make sure that it's always append-only. And there are observers that can look at the log and then create notifications for downstream repositories and so on. So this was about the trust layer. Now let's move one layer up at the attestations layer. I'm going to talk about just one single attestation. There are multiple other types of attestations. I'm going to talk about SALSA. SALSA comes from supply chain levels for software artifacts. And naming is a little bit hard, but it's made to be like the dance or like the dip. So there are multiple levels of SALSA attestations. SALSA level 1 is the simplest one. It's just saying that this artifact has been built by this shell script or by this Bazel command. But that's the only thing it says. It doesn't have signatures. It doesn't have anything. SALSA level 3, which is an ideal scenario where most projects can go to, actually attests that the build is tamper resistant. So once you build this artifact, you know that this artifact has been built without any alteration from its dependencies. And also the provenance is not falsifiable. If you have a SALSA level 3 attestation for a build, you know for sure that that hasn't been like a file that somebody wrote on its own computer and then uploaded. And then SALSA level 4 adds on top of this the requirement that the builds are reproducible and hermetic. So this one builds the entirety of confidence and trust on the entire supply chain. Okay, now that we have Salsa, let's move to the next layer of aggregation and synthesis. So for now, we have considered just a developer building an artifact. And we saw at the previous level that the developer can create attestations about that artifact. For example, a Salsa attestation saying, I build this artifact at this commit. And for another attestation could be like an SBOM, software build of materials, which says that this artifact has these dependencies with these versions and these hashes. But now this artifact has a bunch of other dependencies as other artifacts. Some of them can be developed by other developers, and they can also have their own attestations. And you might even have multiple developers attesting to the same artifact. So for example, let's consider TensorFlow. The developer of TensorFlow would have their own attestations, like TensorFlow 2.11 that is going to be released soon has been built from this repository at this version. But then, let's say, some weeks later, some other company uses TensorFlow, and they say, actually, TensorFlow has a vulnerability, and we are creating an attestation to attest that we discovered this vulnerability. So now you have all of these identities, developers, you have artifacts, you have repositories. Each repository can have some scoring about the state of the supply chain integrity in it, and so on. You have all of these attestations. All of this creates a graph. And somebody needs to understand this graph in order to create the policies about what do I trust versus what I don't use in my company. So here is the guac project, matches Salsa. The name is Graph for Understanding Artifact Composition. It's building on top of all of this. It's creating the entire meta graph of attestations, graphs, identities, and so on. OK, so I talked about the supply chain integrity projects. But where does Bazel come in? Turns out that this talk is after the bzlmod talk, because Bazel bzlmod moves Bazel to be almost there to providing a strengthened supply chain architecture. We only need just a few modifications, which will probably arrive by Bazel 7, so expect them to see soon. Also, I didn't talk about SBOMs, but with Bazel, you can generate software bill of materials very easily, just because Bazel knows about all of its transitive dependencies and everything inside the build tree. OK, so let's look at Bazel supply chain with bzlmod. So you have the upstream repository. For example, let's consider, I don't know, let's say the FMT library from C++. And you have the Bazel central registry repository. If the developer of FMT or somebody that wants to use FMT inside the Bazel project creates a PR to mirror the upstream repository into Bazel BCR to say that now there is this Bazel module that wraps around the FMT library, this is how you create the module inside bzlmod. And then behind the scenes, once this PR gets approved, there is some automation that would mirror the Bazel module and the source code of the FMT library into a GCS mirror, into Google Cloud. So this is already in place at this time. Now, in order to strengthen the supply chain, we need two steps. One step is for this automation to also generate an attestation that says, this developer created this PR to add this dependency, and we mirrored it, and hashes everywhere, and signatures. And the other one is the upstream repository itself can also add its own attestation to strengthen its own supply chain. And then the attestation from the automation can point to the other one. OK, let's look a little bit at the vulnerability management and Bazel. At the moment, there is a discussion in Bazel about what to do if one module is discovered to be vulnerable. Do we want to yank it, so any project that is downstream and want to build from it can no longer build it? Or do we want to send some notification? There is another project that the GOSST team is working on, OSV, for a better feed of vulnerabilities. And we are working on integrating this with Bazel, such that when you are running Bazel build on a project that uses bzlmod, it can link you to the OSV identifiers for the vulnerabilities. And we are going to create more tooling to automate the module version updates. So if a module is vulnerable deep into your transitive tree and you are using Bazel with bzlmod, it will tell you this, you need to update this and this and this, run this command, and everything will be updated. Okay, for the supply chain items, there are two more things that we want Bazel that we are working with Bazel to generate. One is generate as bombs from just a single command. So, for example, you can run Bazel as bomb. The command might change, and it will look at all of the build files that you have, and it will generate, okay, this artifact that you are building, this binary, has these dependencies. Here is the bill of materials, the ingredients. And the other one is to generate salsa directly at the Bazel build time. So right now, this is for an example repository. I have a repository that builds two binaries with Bazel. One is Fibonacci and the other one is a hello, so simple examples. Right now, if I want to generate a salsa attestation for that, I have to first build them with Bazel build, then copy them to the root of the directory, and then compute the checksums for all of these files, and then run a salsa GitHub generator is a project on GitHub that can run on GitHub Actions and generate the attestation file, the first one on the slide. What would be ideal is when you do Bazel build with some flags to also generate salsa, it will generate both the binary and the salsa attestation, and then you can upload everything together. And that is all that I had for today. Thank you very much.